All right, we're gonna sound off. I'm gonna sum up today because today's been groundbreaking, revolutionary. My name is Revolution. Devram, look it up. Revolution. That's my name. So we've done some revolutionary stuff. First, I'll start simple. Oh, there's still some drink in here. It smells fresh. I don't care. It's fucking tea. Don't tell me anything about it. I don't care about the brand. They're greedy pigs. I hate them. I'm not. You know what? This is fine. It's what I have. It's what I have. Nothing special about what I drink. Tea is special, not that. This is it. This is. Oh yeah. And it's sort of good. Okay, it's fine. It's not bad. It's decent. I don't care about it. Anyway, I digress. This is what I'm talking about. This bullshit. Quantum mechanics. All bullshit. I'm at point 1.2.4. 1.2.4. Okay? 1.2.4. It's already a lie. It's already all bullshit. I'm going to prove it to you. I'm going to prove it to you right now. We don't know a damn thing about quantum. We don't know a damn thing. We know there was a wave. People were so bent on the wave. The wave was going to describe it. Einstein came along and said, you're all dumbasses. You're all idiots. Every one of you is 20 years old, mind you. Mind you, 20 years old. He said, what does a photon look like? Imagine it's not a wave, it's a particle. And classical mechanics, bing, shoots a particle. It's sort of like that. It's a photon. We have a photon. I can imagine it in my head, he said. And he also discovered the whole relativity. I don't think anyone understands that anymore. I'm going to look into that now. Not this. I'm going to show you something. Bullshit. That's what I'm going to show you. And not from the book. My work. I'll show you. Let's do this. I can't even do it. Fuck. I'm going to have to switch the camera around. You're going to see all my stuff. What an embarrassment. And it's trash everywhere. Trash. Just trash for miles. So I don't want you to see that. And it's not bad over there. And I can't even see my camera anymore. Let's see. How is it? Is it still viewing? Let me see. I have to demonstrate it somehow. Yeah, it's good. I think it's good. And I hope you follow along. And if it doesn't matter, I'll redo this video again to show you what I'm talking about. I'll redo it again because I have it on Instagram and the bastards won't give it back. I can't even download it, but that's here or there. And I have designs in here, so don't look at my secret designs. Any of them. Okay, this is the one. This is called the Mach-Zehnder interferometer. And it's complete bullshit. Look at this. I'm gonna find you a good example of the Mach-Zehnder interferometer. Oh my goodness. Where are we? We're almost there, but we're not quite there yet. And we're gonna break the ground and we're gonna plant the seed where it belongs. Not with bullshit. Einstein came along and said, you're all dumb. You don't know what you're talking about, and it's a particle. I'm telling you, it's a particle. He was 20 and they ignored him. Well, go figure. And then we got lost track of the truth. He said, no, it's a wave, and that's what we go with. But I'm going to point it out to you right now. This is the Mach-Zehnder interferometer. And you know exactly what I'm talking about when I say it's bullshit. Just look, a beam splitter. They give me a bullshit, and I don't eat bullshit. Nothing unclean touches my lips. I swear, nothing unclean touches me. This is bullshit. You shine a laser, and technically what you have here is a beam splitter. And theoretically, a beam splitter is a semi-transparent medium and semi-metallic. For example, silver. So you put a 50% silver solution in there in your glass or whatever. First of all, this experiment doesn't even count for refraction, which drives me nuts because it's not complete already. I can tell this is total bullshit. And they're even telling me it's bullshit. And I circled it specifically because it's bullshit. And this phase shifter, also bullshit. I've never seen one of those in my life. I'm not an optics guy, but I've never seen a phase shifter. You have to impedance match the whole medium if you want to change the phase. I don't know how else to do it. Or rebuild your apparatus to account for the length. You pick up your choice. I don't care. Length or medium, that's all that matters. And that's all that it is, okay? The beam splitter is technically made out of 50%. 50% silver or 50% transparent media. Either way, you want half the beam to split. It's a mirror, another mirror, recombines at a beam splitter again. And the idea of this interferometer is to demonstrate destructive interference in light to prove that it has a wave nature. And they lied to us. They gave us bullshit. The beam splitter splits the beam. I'm going to give you two pen colors. And it goes up or it goes lower. Okay, it goes upper or lower. Now here's the bullshit part. They want me to believe that it hits this mirror, comes back. This one hits this mirror, comes back, and recombines here. Naturally, this is another beam splitter. So half it will be transmitted, sorry. The transmitted will be red. Ooh, they're both kind of transmitted. Let me show you the numbers. You had 50% here, went this way. You did 200, okay? You shot 200 photons. And you're already assuming that this is using a photon. You're not even starting with a wave. You're starting with a photon, okay? So that's the first sign of a bad experiment, a bad example. 50% of them out of the 200 go this way. 50% go this way, okay? Bear with me. You still have 50% here going this way. And you still have 50% going this way. Oh, it just boggles my brain. Now, when you recombine, you have a different little thing going on. You have 25% going this way, 25% going this way, and 25% going this way, and 25% going this way. From each root, each length, the upper or the lower. I've lost the word. I'm not going to waste time looking for it. So you have 25 here, 25 here, 25 here, and 25 here. Okay, dyslexia, whatever, I don't care. Okay, now, the idea is that when they recombine here, we've lined it up, our apparatus, so we can adjust the phase angle, the phase difference of these two, I want to say, what do they call lengths? Whatever, lengths. These two lengths, stretches, arms, these two arms. Yeah, you recombine, and so now you have another situation like this one. 25, let's just look at the stats. 25 should go this way, 25% should go this way, 25% should go that way, 25 this way, and that way. There you have 0.5, 0.5 each on each detector, okay? Right. We've matched the phase angle. Now we're going to adjust the phase angle. I'm going to show you what happens when we adjust the phase angle. And here we have a little example here. That's a different interferometer, and we'll get into it later. Now the idea is here. I hope this is on camera. Okay? And I have the example here. I did it before. So just you can reference that. The idea is at zero phase difference, they're exactly in phase. 100% of them, or in our experiment, 200 photons. We're already talking about photons. We're not even talking about waves to prove that it's a wave. And the science started, it should have been a wave. They should have been able to do an experiment, at least with a wave, to prove it's a wave. You shouldn't have had to use a photon. Einstein's discovery to demonstrate that it's a wave. It's all bullshit. 100% of them land on N1. That's here. Oh wait, sorry, N2. Sorry, that's here. N2. I'll circle it here with red. N2. You follow this sinusoid for your phase angle difference, and you realize that when they're perfectly in phase, 100% of them land on N2. That's this detector. This detector here, 100% will there. Now you realize, technically, if you have constructive interference, destructive interference, we'll talk about constructive in a second, because it's not even a part of this. It doesn't exist in this experiment, which is bizarre. Why not? I digress, but we continue. Okay. When they're 180 degrees out of phase, now you can see the beams from each arm, the photons from each arm are completely out of phase, and they add up by superposition principle to the middle region. Should be zero, right? Technically, we believe that. Why? Because we don't see any detection. None. There is no detection on either beams, on either detector. We say there's destructive interference, right? That's what we say. Destructive interference is occurring. We don't see anything because of the superposition. Or 50% chance of it landing here. Sorry, 50% of it chance of landing on this one. That's destructive interference occurring. We no longer know what's happening. There's a distribution between the two, and we prove there's destructive interference. That's a wave property. Okay? It's acting like a wave. And that's one photon at a time. One photon at a time doing that. When we're here at 90 degrees, 100% will land on which one? Which one does it land on? Which one does it land on at a 90 degrees phase shift? Huh? Tell me. For this one, they subtracted. Or did they? They averaged, okay? They added and divided by 2. That's what it looks like to me. What up here? No. What happened here? What happened here? I wonder. Something doesn't make sense. It's got to be the difference. Let's see, D2. This is the equation. D1 is a subtraction, and D2, okay, it's an added and subtraction. That's what's going on. That's what's going on. That's exactly what's going on, okay? This equation, when they're completely out of phase, demonstrates that half of the time, it's going to land on D1 and D2. And that's the same in this situation and this situation. It's like an aliasing almost. That's what it reminds me of. At this point, they're equal. Okay? What's cos of pi over 2? I can't remember. I don't have a calculator. Holy shoot. 1 second. Okay. I have to think because now I'm doing the nitty gritty. It looks different. I did this without paper last time. I have to think. My question is, you put D1 and D2, what are they? What are they? At 0. At 0, cos is 1. At 0, cos is 1. Forget the n. We know that's just a statistic weight of our experiment. We don't need to consider it. We're going to get it. And we know it's going to be statistically distributed. We can just do this. This will be 0. It won't land on D1. And this one, it'll be 2. It'll be 1. It'll be the 1 will land on this. And you just weigh it according to how many times you do it. Doesn't matter. They derive this from experimentation, apparently. So look at 0. What does it say? At D1, it's going to hit every time. Right? Detector 1. I backwards them. Should be up here. 100% of the time it lands on N2, D2, here. Over here, I hope you see that. Over here. Lands here 100% of the time. Demonstrating interference. What's cos of 90 degrees? I can't remember. I can't remember the cos of 90 degrees. What does it look like to you? Looks like n over 2, right? Looks like 50. I think that's what it is. 0.5. So what's 0.5? It's 0.5 over 2. And this one's 1.5 over 2. Times the weight. Right? Something's wrong. I made a mistake, I think. Superposition means something like, I thought that you could just, I thought constructive interference just added them. I thought it should just be, it should bring you up to a full strength. It should be a full strength. It should be 0 here and 1 here. And this is the equation. Where did this equation come from, I wonder? I really do wonder. You have constructive interference. If these are 100% out of phase, I'm telling you, how do you add the sinusoid power? How do you add the power? This is different. It's a different equation. It's not simple. It's not like a wave in the ocean or something. Something else is happening here. I wonder. I really wonder. Why'd they give me this? What did they say? I wonder. I'm not going to look at the book. I don't need it. It's all bullshit. Naturally. This is really bizarre now. I'm really tripping. It's totally got me at a loss. But we continue. We digress, but we continue. Is that on the right side? Yeah. I guess so. 180 degrees out of phase. We get 50-50. We get half on N2 and half on M1. So this is our 0. We'll just call it 0. That'll make things easier. And we'll just say it's 50%. And here, there should be no sign of anything. Should be completely destroyed. Which is 50. 50-50 as well. So weird. Every 90-degree phase shift is saying it should be 50. I don't get it. It's not what this says. This says 0.25, and this one says 0.75. So 5% of the time. What's going on here? Something's up. I don't know. I don't know anymore. I'm lost. Totally lost. When a wave interferes with itself. When the wave interferes with itself. At this point, it's always going to be N2 100 times. At this point, it'll be always N0. Here's the opposite. It's always N1. Here's N1. So bizarre. Here it's saying 50-50. 50-50. Not here. Not here. This is wrong. Should have been here, here, and here. Okay? Fair enough. I don't care. It's just out of phase a bit. My idea, my phase was angle was 9 degrees off. So anyway, I continue with this assumption, the presumption. 100% here. And 100% here. And here we demonstrate destructive interference. Half the time it's there. But my point is this. This is what they wanted to draw. I don't know where they got this. I don't know. This is experimental. It's experimental. So no shit, Sherlock. Look what you did. You sent it through a beam splitter where 50% go this way, 50% go that way. Go figure. 50% go this way, 50% go that way. They both split the beam split. They add up back in to 50%. Right? So what did we build here exactly? Anyway, out of a photon, out of a photon from a laser, a binary random generator basically, with a 50% chance to go this way or that way. Nothing to do with a wave. Purely defined by a particle. Doesn't prove shit. Proves the probability of the photon hitting a mirror atom here, bouncing up, reflected, or probability of hitting a transparent medium here and bouncing there. That's all it proves. That a beam splitter exists that can probabilistically bounce it. Okay? And then we have the same apparatus here set up with another 50%. Nothing to do with interference. Has nothing to do with interference of a wave. Sorry, I'm just doing this so you don't see the mess. Nothing to do with interference of a wave. Absolutely nothing. Probability, that's all. Random binary generator. That's all it is. That's all it is. And to add insult to injury, they proved gravitational waves. No shit. It's called the tidal force, the moon. And when you deal with quanta, those little fluctuations in space make a difference. When you stretch an object with gravity, it makes a difference. When you squeeze it with gravity towards the lower bottom, stretch and squeeze, That makes a difference in quantum mechanics. Mechanics, quantum mechanics, not quantum fields. We don't say quantum field. We don't say quantum field. We say quantum mechanics. That's what this book is about. Excuse me. And it's bullshit. The main experiment that we started with doesn't imply, it's not only if it's a wave. If it's a wave, maybe. Not only if. Not only if it's a wave, this happens. If it's a wave, it happens. And there's a difference, big difference. If it's a particle or a wave, then this happens. If it's a particle, if it's a wave, and only if it's a wave, we don't have shit on that. We don't know. We don't know what's happening. Not at all. I think it's all bullshit. Quantum waves, the moon, think about it. It has nothing to do with the quanta. Big objects can change the quanta. The quanta doesn't change the object, the big object. Not yet. Not yet. I'm going to show you how to do it. That's what I'm going to do. That's what I'm here for. That's what I came to do. To show you how the small changes the big. And I'm going to start with the big to look at the small. Like the gravitational waves we get. And we're going to look into relativity because no one understands it. That's the problem. Everyone's a fucking out to lunch. Everyone's talking about the butterfly effect. The butterfly effect. That did nothing. Okay, I try to tell it to you. I'm going to tell you gently. That did nothing to China, okay? Can you get that around your head? This doesn't affect China, okay? No. The butterfly that went through a metamorphosis. Now that's cool. A metamorphosis is cool. But its flapping wings don't do shit. Nothing to China. I swear to you. Believe me, it doesn't affect China. There's no hurricane in China because the butterflies are fighting with the wasps or whatever the hell is happening in the ecosystem of their habitat. I don't care. It's not affecting China, believe me. The moon, that supermassive objects floating around the earth, that pulls the tides up and down, okay? That's the key. That's the first important fact. This pen is big enough I can demonstrate it, and it feels light. And there's that. And what else is there here? And this spoon is about the same size, and it feels a little different. It feels a little heavier. Okay, there's a difference. And I don't care, there's something, and that changes the way we see the tiniest part of that. Okay? Okay? One gas atom in here, diffused in this iron, this steel, one gas atom in here, a carbon, whatever. Maybe it's not even gas. It could be gas. It doesn't matter. It's diffused. Something's in here, diffused in here. Makes a difference, but a small one. This is like 90% iron, whatever. I don't know the number. About 90%, yeah. 85, 87% iron. And that's why it's heavy. That's why it's heavier than the pen. Not because of the single carbon, or the single element of carbon in here. And that's the difference. The macroscopic. We humans, we observe the macroscopic. And that's the way we view the world. We don't view the microscopic. No. We don't see the world by the microscopic. Our eyes perceive the whole picture, not the little picture. It's a big difference. That's bullshit. That's what destructive interference shows us. We had destructive interference, and we had constructive interference. So what? So what? You had constructive interference on what? You can't even tell me with 100% certainty that it even interfered in the first place. You can't tell me that. I don't believe you. I don't believe it happened. You went out to say Einstein was an idiot. You're an idiot. You don't know what the fuck you're talking about. And pardon my French, but it's really true. Don't diss the man. You can't wrap your head around it yet. That's the problem. I've been to conferences where they talk about the curvature of light, and that's not an EM phenomenon. That's not an electromagnetic phenomenon. That's a particle phenomenon, and we can see that with our eyes when we look at a black hole, and it's got a corona around the outside from the star behind it. All the stars behind it, the light curves because the gravity pulls the particles, right? They have a low mass, believe it or not, and they have an attraction, and that's the only field that we're working with. The EM field is different, and it's wrong. Something's wrong about it. Why is there a particle for a photon? Why is there a particle for a photon? What about the rest of the spectrum? What about your microwaves? What about your gamma rays? What about your X-rays? What about your infrared? Infrared, people get it. It's a lower frequency. It's a larger wavelength. And that makes sense to us. Little tiny packets of energy popping around. We deal with that all the time in thermodynamics. X-rays, we don't know. Decay. Think about radioactive decay. We're losing mass till it's obliterated. No more X-rays. It's all just a mass. It's all mass and gravity. It's relativity. And I can't believe no one's touched relativity for what is 130 years. 120, 130 years. No one touched relativity. And Einstein was 20 years old when these guys came and ganged up on him and said, there's a wave. And look at all the shit we're doing. He was a patent officer. He wasn't anything. He was just a genius. No, we're going to pick up where he left off. Not with this bullshit. I don't have time for bullshit. And nothing unclean touches these lips. No way. So that's it. And we start. Yeah. Red, green, and blue. This, that, and the other thing. Red, green, and blue. I can see it on my TV and I believe it. Because those 3 LEDs or whatever, liquid crystal, I don't know the technology that well. Those 3 lights, I can see the whole spectrum of visual light. Just like I can see the sun. That gives us the visual spectrum we have. The exact temperature of the surface of the sun. And that's heat. That's heat. We know that. We know what that is. What happens when we go further, a little higher in frequency? What's happening with the aurora borealis? Alpha particles, beta particles. That's only the first. That's the beginning. That's the beginning of the alphabet. We'll read between the lines, okay? If you can't read between the lines, you can't touch my shoes. You can't touch my shoes if you can't read between the lines. You cannot. No. Alpha and beta, we're just on the surface of it. The aurora borealis, and that's right here on Earth. It's not on Mars. We don't have to go far. We can find the answer right here. And that's what I'm going to do. And no one's going to get in my way because you all slow me down and waste my time. Okay, that's my sound off. I got it on IG TV. They took it, they won't give it back. That's just the way it is. Anything goes there stays there. But I'm putting it up on the YouTube. Not the porn tube, the YouTube. The one everyone can watch and learn and see something real. Not fornication. Not satanic shit. Whatever. Disgusting. And I'm guilty of it too, don't worry. I'm the guiltiest there is. But I try to at least make the balance add up at the end of the day. And I put a lot of energy into putting the balance to even. Because mine was like this. And I had to put a lot of energy to bring it back like that. Okay? So we're going to go from there. I'm going to start to do it on YouTube because my videos are not really coming back to me from IGTV. I need to be able to access them. So YouTube's going to be the medium or the platform for me. We'll slowly start to transition over. And Interferometer bullshit. Gravitational waves, really. The tides, tidal forces. Binary random generator. What happens with the light? What's going on? Constructive interference, destructive interference. Demonstrate that just with 2 lasers. What happens when you completely destroy 2 lasers? Shoot them at each other, out of phase. You get 0 light. Where did the energy go? Where did the energy go? Tell me that. What happens with constructive interference? It's gonna hurt your eyes more probably, I can imagine. You're gonna shoot 2 lasers out of phase at my eye, and it's gonna be black? You mean blind me, or you mean there won't be any energy hitting my pupil? I don't know. I really don't know, and it's bizarre. I know they're wrong at this point. I already knew it. As soon as they told me it was bullshit. As soon as I noticed, and there's another interesting observation, they bullshit me too again. They say we know the probability, and they give it on, and we see it on 2. And you have this chart. You have this chart. This is theoretical. We say okay, we know, we observed it. That's a perfect plot. Mach-Zehnder interferometer just defines that. Aspect Roger and what's his name? What's the other guy? Aspect Roger did the experiment. It wasn't even the guy who built his apparatus to prove this. Couldn't even do the experiment himself. He got his cronies to do it. Aspect Roger and Granger. And they had to put it on 2 graphs, not 1. They had to put it on 2 graphs. I've seen that all throughout my university career. And people would just fudge the numbers however they can. And they did it so well you couldn't even tell because they put it on 2 graphs. We started with 200 photons. First of all, photons, not waves. 200 photons. And they had results for 400 photons. What happened? What went wrong? It's a conspiracy. I don't believe any of this. And it's slowing us down. Slowing me down. Alpha and beta particles, that's it. That's the beginning. The green light. The green light that says go. It says go. It's green. Emerald. The Emerald City from heaven. And that's what we're going to get at. And I've seen things. I've seen things with my own 2 eyes. And visual hallucinations, extremely rare. Extremely, extremely, extremely rare. Only me. That's how rare. Visual hallucinations. Auditory, common. So common, thousands, all the time, non-stop. I'm a schizophrenic. So I'm excused. Okay? And that's it. I'm petered out. I'm getting tired. And I've been doing this a long time, all day. And I'm going to crack this code. I have some work to do too, which I'll probably get into at some point today. But other than that, I'm just consumed. My mind is just boggled. The people have no shame. They teach a lie. It's a disgrace. Because Einstein figured it all out. He did figure it all out. And it's all there. That's why. That's why they said, no, he's not that smart. We're smarter. At least we can trick him. And he's only 20. This punk. Who is he? 100 years later? Where are you guys? Where are you guys? You're nowhere. You're nothing. Anyway, digress and we continue, but we gotta figure this out. We're gonna set the record straight. Okay. 34-24. That's good for me. Bye.